Hello? Oh, you can hear me. Gracias, thank you for doing this, letting me do the talk in English, and for the nice introduction. I would love to talk to you about my awesome research in the oceans, but I'm just able to talk to you about my research in one organ that is very important for all of us, as humans and mammals. And I'm gonna do a little game with you so that you guess which organ am I talking about. I work not with the organ itself, but with the cells. Cells are the building block of the organs, the tissue, the organs, and I'm gonna show you some. This is evidence number 1 billion, how this organ gets developed, and now I want you to guess. I'm gonna give you some clues, so don't worry. So, you can see a round area, and you can see the tail. I would like to point it, but I'm very scared that we're gonna miss the video again. This is one cell, they're all together, and they kind of know here in green where to go. They are on the happy, perfect environment, and they're moving towards somewhere. You can see they know where to go, they move very fast. Here they have no clue where they are, what to do, they're lost. Again, you can see the process is kind of like a tail, and that's how they move. Once again, the tissue and the cells moving. That's it. I would like to ask you, who thought you were watching eggs and sperm? Okay, less than half. Good. Who thought you were watching neurons, the cells of the brain? Good. 3 persons, I'm impressed. These are neurons in your brain, in case I don't pronounce it correctly. So I am a neuroscientist. I did my PhD on brain development in a very specific type of neurons. In our head, each one of us have approximately 1 billion neurons working right now. And I'm very crazy with numbers, so I always like to compare. On Earth, we are around 7 billion people. And this is 14 times more the amount of cells we have in our head. These cells, specifically in the cortex, they're gonna be very well organized. There are different types. It's like having each individual, each human being with each passion. And they communicate quite well, and they allow us to have emotions, think, communicate. We cannot say humans are doing that well in the planet, in that area, but neurons in our head are. So I really wonder how these neurons get to communicate and reach their area during development, because it's very fascinating. The video you saw is actually a part of the tissue of the brain, and these are very specific neurons. They're gonna move from here to their final area, and they're gonna make you love, hate. They're gonna tune the cortex, that is the area that make you have conscious and higher functions. To have a better idea, each one of us has the brain. This is a mice brain from the top. Each brain has 2 equal hemispheres, left and right. And what I show you on the video is 1/2. During development, some neurons from the cortex are gonna form very close to their final area, and 20% are gonna move. That's what you saw on the video. They were moving from this distant area to their final target. So it's kind of like if we decided to walk from Leipzig Hauptbahnhof to Berlin Planetarium. It's like that's the distance that the neurons have to move. And that's very awesome because I couldn't do it without a GPS, and I wonder how neurons does. And they do it through substances. They communicate and can read the area and have a map through the substances that are in the tissue during development. And it's not only that they reach an important area, but this 20% of cells are like the orchestra director. You have 8 playing an instrument, and you're going to have 2, so 20 to 80%, directing the brain. When the neurons are not reaching their final area, you will have autism, learning disabilities, and many more. And now you might be wondering, okay, great, but why do we care? Well, we care because in the future, out of 10 children, 1 will have one of these disabilities, and the trend is increasing. And this is kind of like a map and a puzzle. And if you don't understand how the brain ensemble, you cannot fix it. You cannot fix the problem. So that's why this research is so important. And now you might be wondering, okay, this is very interesting, but what does it have to do with the oceans? And this is evidence number 323 million. That's the amount of cubic liters of water in the Atlantic Ocean. Substances. As I mentioned, all these neurons reach their target through substances. But nowadays, we all know that there are plenty of substances that are being put into our oceans, into an earth, and in also the air. And now I know what you're telling, okay, point them out. Who is doing that? Catch them, problem solve. Well, it's a little bit more complicated because we are doing that. We, as consumers, are buying and using materials without really knowing what happened afterwards. Even if we are very far away, or we think we are far away from the oceans, we are very connected to it. Because everything we recycle will need some water process that will reach the water bodies and will finally reach the ocean. So that's something I want you to remember. Even if you don't see the sea or the ocean often, you are highly connected to it. The ocean is the main source of water, and we are 90% water. So you should be more aware of it. Now, some researchers have been checking if nanomaterials or microplastics are polluting the food chain, for example. And here in green, you can see microplastic that is eaten or glued to plankton. So even when we recycle, there are going to be some particles that will run from the body water to the oceans, and then it will reach the plankton. And it's similar with mercury. I'm pretty sure any pregnant female knows about it because doctors nowadays recommend to avoid tuna because there is heavy metals stuck on them, and it's similar with the microplastic. The plankton will eat the microplastic, then another animal, then a small fish, a larger fish, tuna, and finally us. I don't want to shock you, but everything we put in the ocean, every waste we produce is going to come back to us. Even if it doesn't reach directly the ocean, it's going to leak some substances that are not healthy for brain development. So now I consider a little bit, okay, I want to run away. That's your cortex right there working, telling you, I don't like to hear this. But please bear with me because this is evidence 3, the resolutions. First of all, just feel the connection with everything you do and everything you have around yourself. Second of all, don't worry, there are a trillion things you can do. Most important, rethink. And give yourself a day of trying to live without plastic, for example, because plastic have many substances that make it malleable. And those substances that make it malleable or resistant to fire have been playing with brain formation. So it's proven that these have been affecting the generations that have been born while this plastic have been reaching us and have been reaching the environment. So if you don't want to think about it alone, you can join festivals. For example, the Refashion Refood Festival. I'm sure in Leipzig you have plenty. Just give yourself some time to enjoy. Give one detox day on a plastic, maybe a Saturday. The important thing is that you discover what's going on, use it properly, the materials, and appreciate it, or get to protect it. Thank you very much. Oh.